And let's do another lesson, 6-6, exponential and logarithmic equations. Let's take a look at this model and discuss. A store introduces two new models of fitness trackers to its product line. A glance, the data is enough to see the sales, blah, 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 blah. Part A, find an equation of an exponential function that models the sales for each fitness tracker. Describe your method. Well, we're going to use what I taught you guys as regards to consecutive points. So for this one here, right? Oh, need the pen, boom. Okay, when x is 1, the answer is 28. 1 and 2, and the answer is 54. What we're going to do is, in order, and let's do this one here. 1 and 1, the answer is 5. 1 and 2, it is 17. Simple. Okay, now, what we're going to do here is we're going to find the b value. So let's do the 28 one, and then the 254. In order to find the value of b, what we're going to do is we're going to take the second number and divide it by the first number. So that's 28. Here we go. Okay, to find the value of b, it's second over first. And in this case, it's going to be 54 over 28. And I can leave it like that. Let's leave it like that. Okay, now knowing that y equals a times b to the power of x, I'm going to use that at any one of these 2 points to find the value of a, and lo and behold, hey, check this out. I can use that point because there's a 1 on top of, or the 1 is the exponent. So I can say 28 equals a times 54 over 28 to the value of 1. Okay? So this means at this point, what I'm going to do is divide both sides by 54 over 28. So a equals 28 over 54 over 28. And that is going to be your value of a, essentially. Okay? So in this case, what happens here? We have everything, right? So that means y equals 28 over 54 over 28 multiplied by 54 over 28 to the power of x. Notice how I didn't simplify it. Left it as it is. Okay, we can do the same thing for the other one. 217 and then 15. Here we go. Let's do it over here on this side. Okay, and I'll do it in a different color. Boop and boop. Okay, 1 and 5, and then 2 and 17. B, we know, is 17 over 5. To find the value of a, let's use this point. Okay, 5 is equal to a times 17 over 5 to the power of 1. That means a is equal to 5 over 17 over 5. So we have our equation. Here we go. Y equals 5 over 17 over 5 multiplied by 17 over 5 to the power of x. We did it. Yay. Okay, we got those there. Notice, again, I didn't simplify. Left them as exact. I'm trying to make it a little less complicated for you guys to show you guys we don't really need a calculator, right? Anybody can do this. Okay, that's me typing on a calculator. Anybody can do that. It's all about doing it mentally. All right, so we have our equations. But now let's focus on this, okay? Now let's focus on solving exponential equations when there's an x in an exponent, okay? So for this one here, what is the solution to 1/2 to the power of x plus 7 equals 4 to the power of 3x? It looks very complicated. Even if we were to drop or attach a log to both sides, it would make things complicated. Notice this. I can rewrite 1/2 as 2 to the power of -1, and I can rewrite 4 to 2 squared. What I'm doing is changing the base, because if the bases are equal, that means the exponents are equal. So I figure out what the 2 exponents are, and then from there, I just solve for x by setting them equal, the 2 exponents. And in this case, x equals -1. Here we go. This one here, 25, 3x, 125. We can change this as base 5. So I'll put the work over here. Okay, it's 5 squared, okay, to the 3x equals 5 cubed to the power of x plus 2. We have 5 to the 6x equals 5 to the 3x plus 6. And since the bases are the same, the exponents are the same, 6x equals 3x plus 6. 3x equals 6, x equals 2. that simple. 0.001 is 1 over 1,000, which means it's 10 to the negative third power, because 1,000 is 10 to the third power. So this means, since the bases are the same now, negative 3 equals 6x. X equals negative 3 over 6, or negative 1/2, your choice. There should be no questions in this. Actually, there should be a question, because I bet you one person say, well, what if you can't change the base? What if the bases can never be the same? Well, that's going to come up, Mr. Sally. What if you have this? Now we can attach a logarithm to both sides. It's from the trick that I taught you guys earlier. This one here is just going to be log of 17 over log of 4, more simply put. This one here, log of 12 over log of 5. It's that simple. Okay, so it really depends on what you're working with here. So the trick would be, if you have an exponent and it's just x on top of a numerical base, you know that that's going to be on the bottom, log of whatever that number is. And if there's a number without a variable exponent, that number's on the top with log. That's simple. Okay, this example here. This is where, Mr. Sally, is saying that you can't change the base, right? He's going, well, 3 to 5, you can't do it. It's not possible. So this is where we attach a log to both sides so that we can drop down the x plus 1 and then the x. And then from there, we solve for x, okay? Log of 3 is a number. And what they did is that they distributed the log of 3 to both values, right? And then from there, we move we move anything that does not have an x to one side, anything with an x to the other side. So what happens here is this x log 5 moves over here by subtraction, and then we can factor out an x. On the other side, it's negative log 3. So I divide both sides by log of 3 minus log of 5. Bam, there's your answer there. So let's actually do this. It's actually not that bad, okay? So first things first, I've got exponents with x's, and I can't change the basis, so I'm going to attach a log. So log of base 2, 3x equals log of 7, x plus 1. Okay, I'm going to drop down the exponents. 2x log of 2 equals x plus 1 log of 7. I'm going to distribute the log of 7 to both terms. 2x log of 2 equals x log 7 plus log of 7, okay? Then what I'm going to do is I'm going to move this x log 7 to the other side because that contains an x. So it's 2x log of 2 minus x log of 7 equals log of 7, okay? I'm going to factor out an x. So now I have, in this case, 2 log of 2 minus log of 7 equals log of 7. And then after that, I divide all of this to the bottom. So then x equals log of 7 over 2 log 2 minus log of 7. That is it. And that is the exact answer. It's the exact answer to this. Okay? It's a little difficult, but it's all about piecing the puzzle. In fact, I might even put a question like this on your quiz that's coming. I'm thinking about it. Here we go. Using an exponential model. Okay, so let's look at this. The diagram shows how a forest fire grows over time. The fire department can contain a 160-acre fire without needing additional resources. About how many minutes does it take for a fire to become too big for the fire department to contain without additional resources? This is something that they mentally think about when it's fire season, okay? So obviously the less resources that there are, the more the fire actually is able to spread out because it cannot be contained. That's important, okay? So let's take a look, let's take a look at this. Notice this, right? When t is 0, it's 4. So we're looking for the base, okay? So notice how when I divide 7.2 over 4, I do get 1.8. So then I found my equation. And then my beginning number is 4. So my equation would be this. We need to set it equal to 160 because that's the acres. that we're covering, okay? So we then need to figure out what t needs to be. Again, we attach a log to both sides, bing, bing, boom. There you go. There's your exact answer. Okay, again, I divide by 4, log, boop, boop, we're done. So let's do this. About how many minutes does it take the fire to spread if it's 100 acres? Well, we're gonna set this equation equal to 100. So here we go. 100, and 4, parentheses, 1.8 to the power of t. Divide by 4, 25, equals 1.8 to the power of t. And we have our answer. Check it out. T is equal to log of 25 over log of 1.8. And we did that from the previous example, right? Because we dropped the t after attaching logs and we divide both sides by the number that had the t as an exponent with the log. Not difficult. Here we go. Now, look at this. Oh, no. There's ln on both sides with variables inside. Well, the base that we're using is base e. So if we attach an e to both sides, notice how the ln's go bye-bye. We're given now quadratic equations. Set it equal to 0, bing, bing, boom, you're done after solving for it. Now keep this in mind. The -2 is not gonna work. Because if I plug in -2 inside the ln, I cannot ln a negative number. So the only number that would work would be 8. Notice how both the solutions are there. So let's do this real quick. Okay, we're gonna do this on a separate sheet of paper. Log of base 5, x squared minus 45 equals log of base 5 of 4x. So here we go. Okay, you scroll down. So log of base 5, x squared minus 45 equals log of base 5 of 4x. Okay, so now what we do is we attach a 5 to the bottom of both of these. Why? Because it's base 5. So we have x squared minus 45 equals 4x. We're going to move the 4x to the other side. X squared minus 4x minus 45 equals 0. Let's magic x's, -45, -4. It's 9 and 5. 9 is negative. X minus 9, x plus 5 equals 0. And the only one that's going to work is this one. So x equals 9. Voila, done. Absorb it, absorb it, absorb it. Here we go. Moving on. Oop, I did not want to do that. Nope, moving on. Here we go. Okay, let's do another example. Just like it, ln of -4x minus 1 equals ln of 4x squared. So ln of -4x minus 1 equals ln of 4x squared. This involves base e. So e -4x minus 1 equals 4x squared. We're going to move everything to the other side, set it equal to 0. 4x squared plus 4x plus 1. And here we go. So 4 and 4, 2 and 2. We got to expand because there's a number next to the x squared. 4x squared plus 2x plus 2x plus 1. Boop, 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 boop. We see what we can take out from each group. We can take out a 2 and an x. Boop, 2x plus 1 plus 1. 2x plus 1. These are the same. 2x plus 1. 2x plus 1 equals 0. So the only x would be -1/2. But let's check and see if it's going to work though. Okay. And it looks like it is. Why? Because when I plug in -1/2 into here, I get a positive number. And when I plug in -1/2 into here, I also get a positive number. So guess what? That's the answer, and it will work. Check mark, smiley face, and how about little blue? Because I know he wants the attention. Okay, moving on. Let you guys absorb for a few more seconds. I'll scroll up. Absorb, absorb, absorb. So here we go. Moving on. We have 2 more examples. Oh, we have less example. This one here, it's just basic graphing, right? You can Desmos this. Anytime you have a logarithm equaling to a variable expression with no logarithm, just graph it. Just Desmos it, find where they intersect. I'm not even going to go over how to do this. Just know how to do it. Okay. Notice part A and part B, right? It's basic, just basic graphing, because you can't do this by hand. You cannot do this by hand. So you have to Desmos this lesson or this example here. Okay, that'll conclude 6-6. We are done for this. 6-7 coming up. Check out the vids.